Hello everyone! Today we will talk about how data sharing and standardization can speed up the process of developing new materials and overall the progress in science. With us we have, as a presenter, Tomas Storck, which is a data team lead at VS Particle. He will introduce us to the best programs and to the best practices to use your data and share them with an open source system. Thank you, Tomas. I will give you the floor.
Ale already briefly introduced me. I am Tomas Storck. My job at VS Particle is that I'm one of the people that started the data team, and that is looking into how we can utilize data within VS Particle to do some real cool modern things, basically, in the company, and make use of the data to do some clever things, some clever research. So what I want to talk about today is to a large extent my personal experience. I will go into a bit more detail on what exactly I've done in my career so far, and also why I particularly like to talk about this topic, and hopefully I can teach you a few things about this as well. So before I start the actual presentation, as I mentioned, I want to give you a bit of a perspective on why I'm doing this. After that, I will talk about what open source is, about the importance of open source, or the possibilities of open source. I'll talk a little bit more as well, especially with a more critical note on the economic feasibility of open source, because there's a reason that it's not utilized everywhere in the world right now. And I'll have two slides prepared on a couple of tips that hopefully you guys can use in your daily work, and focusing there on the data storage and on how you can publish your work. So the reason I'm talking about these things is because there are two things that I really want to teach you during this presentation. First of all, I want to make you enthusiastic, of course, about the stuff that I've been doing, about the stuff that you can do with open source, and about the stuff and the role that material pioneers can play in this. And second, I want to give you a handhold, give you a start on what you can do with these principles. So that's me on the right. Just 1 week before Corona hit. And you might have noticed, if you had your screen on, if you were looking at the presentation before we started, my hair is a lot shorter now. The barbershops in the Netherlands are closed. And that means that the lady on the left, my partner, has been cutting my hair since. Other than that, it's really me. So I am one of those people that grew up with computers. I think I'm one of the first people that grew up with computers in the 90s. They became from something that not many people had to something that's in practically every house now, is actually disappearing from the houses again, and everybody's moving to their smartphones. But I'm one of those people that basically since I was 12, I've been playing around with these things. When I was 12, I actually started doing some freelance work with people, repairing computers, explaining Photoshop, developing websites, anything really that was related to computers, and that I could understand, at least to some extent. I like to work on that, and I did that for about 10 years until I moved out of the country. But before I started my bachelor's, I thought, look, this computer thing, it's really nice, it's really fun, but there's more to this world than just computers. And that's the reason that I didn't do computer science or informatica or something like that. But I actually started working on chemical engineering. So not necessarily working with computers, but getting an idea of what other things you can do by just thinking logically. I really enjoyed doing this. I didn't do much with computers at that time until I started doing my master thesis. Just before that, I had a course on numerical methods, and that basically allowed me to combine my computer skills and enthusiasm with the scientific knowledge that I built up during my bachelor's and my master's. Really liked the combination, did a very fun master thesis. And through my professor at TU Delft, I got in touch with a professor at the University of Queensland in Australia. And that's where I went to do my PhD. So during my PhD, I did a modeling study on how microbial cells are interacting. Spent 3.5 years in Australia, had a very good time there, and afterwards went back to the Netherlands to more apply my skills. So I had a lot of academic knowledge, which is very useful, of course, but one of the things that bothered me during my PhD is that I worked on something, and after 3.5 years, I figured out, okay, this is something that's not going to work for the next 30 years or so. Now, that was rather demotivating for me. So I started working in industry. And the first thing I did after I came back to the Netherlands is I found a job at a consultancy company called Alten. And there I worked as what they coined a scientific software engineer. I really like the term. Basically boils down to, hey, you're good with computers, you understand science, let's combine the two and do some interesting research with that. And the research I did mostly at Alten is together with a team from the Shell, I developed a model that tries to understand the earthquakes that are happening in Groningen, as Groningen is a province in the north of the Netherlands, for those who don't know. And with that model, we try and understand where these earthquakes are coming from, and also, of course, to try and minimize the impact of these earthquakes on the province, while still having a commercial driving force, or still wanting to get this gas out of the ground. After I did that for about 2.5, 3 years, I think, I started looking for a different challenge where I was able to work on more diverse things. And that's how I got in touch with the management team at VS Particle. One of my old study mates, he's one of the people on the board there. And he said, hey, we're looking for someone who's good with data and with computers and with science. Well, that's in this case, that was me. So I joined VSP in May 2019. And I, after a couple of months, I started as the head of the data team. So trying to send the data team in a direction that's good in the long term. Well, and that's what I really like about my position, while still being able to do hands-on work. So I hope that explains, to some extent at least, why I am the person doing this presentation. Through my work at Alten and through my PhD, I did a lot of software engineering, and I got in touch a lot with open source, version control, and all kinds of other things that are relevant, in my opinion at least, to the field that you guys are mostly working in. Let's call that materials development. So I'm one of the people that understands open source, but I'm also one of the people that at least has a basic grasp of the work that you guys are doing. And hopefully I can be on that interface to try and translate the knowledge that is in software engineering, especially related to open source, to your field. So starting with what is open source? And I'm just going to, I'm just going to alt-tab back to the Teams presentation. I'm curious to hear if anyone is familiar with the term open source. So can you raise your hand if you've heard that term before and if you have a basic grasp of what it means? That's a lot of people, actually. So already, I won't wait for a minute like I did before. I see that already 2/3 of the hands are up. So I won't go into a lot of detail there. One of the things I was planning to talk about, though, is Linux. Is anyone familiar with Linux? Good. So now I've got something to talk about. So I think about roughly half the people know about Linux. So I'll go into a little bit of detail on what Linux is without making the presentation about Linux, of course, because we're going to focus on the open source part. So just reiterating what open source is. In my own words, it is the permission to use and also to make changes to something, and something can be a piece of software, can also be a bit of data, it can be a principle, can be a design. You're able to use and modify this to the fullest extent of it. And that means you're able to just download the program, let's say, make some changes and publish it again without having to go through extensive copyright statements and all that. Generally, if you use open source software, the only thing is that you need to quote or you need to cite where this is coming from, where the basis of your work is coming from. Other than that, you're, depending on the license, of course, you're in open source often able to just get a product, improve it to an extent that you think, hey, this might be commercially feasible, and you're even able to sell it in many cases. So it's the ability to get a lot of freedom in the things that you're going to work on. Now, the most famous example that I thought of right then was Linux. Linux is an operating system that's used a lot in software engineering, especially to run simulations. It's very good at managing memory, and with that, quite efficient as a computing cluster. But it's also an important thing where websites are hosted. A server is often running Linux, and that allows it to basically serve, let's say, Wikipedia something to you. So initially I thought, okay, let's talk about Linux as an example. But then I realized that while I was looking up Linux, I went to Wikipedia. And in Wikipedia, I used Firefox to open Wikipedia. And I'm actually running Firefox in the screenshot on my Android phone. All these things are at least to some extent related to open source. Tux, so that little penguin symbol that you see there, that is the symbol for Linux. I downloaded that from the Wikipedia article. Firefox is an open source browser, and Android, I don't know if many of you know, but Android is actually based on the Linux kernel. So the thing that you're running on your phone is actually in some fundamental way based on Linux as well. And of course, it's got a lot of extension on it. But yeah, it's hard to say what the most famous example is of open source. A very good example of open source data would be Wikipedia. Wikipedia, you can write it, you can edit, you can do anything you want with it. And yeah, that's probably, at least in this community, I think the best known example for open source. Now, I won't go too much into detail, but it's good to know that, well, in the old days, and I'm talking the early 2000s, open source was something that was hardly being used. At some point, the CEO of Microsoft called Linux a cancer, actually. He called open source software a cancer. And that has changed a lot. Nowadays, the new CEO of Microsoft is actually using things from Linux in Windows. So now I'm working in Windows at the moment. I'm able to use Linux, though, from within Windows. So this concept is this idea about open source being bad and being not realistic. That's nowadays mostly gone. And it's doing a lot of things, especially in the background. The links that I've got here, I've got a lot of links in my presentation. These links are clickable. I will share the PowerPoint after the presentation, and you can actually click this to read more about it if you want to. You don't have to, but it might be an interesting read from you. So in materials development, there is also a lot of open source present. I would call open access publications open source as well. And that especially focuses on sharing your research data. That's a trend that you probably see a lot more in your work as well. It's nowadays often possible to just download the data someone obtained and, for example, make different plots with that. Another example is the Hde Jcap database. It's a materials database that I actually heard from some of you, from Pedro, and I think from Niels. I heard this a couple of weeks ago on the 24th of April. Yeah, it's a really interesting database where a lot of materials are present with a lot of data that you can just use free of charge. Another common example is Python. Python is a programming language that I personally use a lot. And a lot of Python's libraries are also written in open source. So not just Python, but also most of the libraries that you use this way. So a lot of people are able to just open Python, make changes, and publish it again if they want to. And often they publish it back to the source of Python so that, for example, if I would make an improvement in Python, you guys would be able to use that improvement as well in generally a number of weeks, sometimes months. Why is open source important then? One of the big advantages of open source is that it allows, or basically forces, transparency. The steps that you've taken to obtain a certain result are shared in your open source work as well. And if you find out that the results obtained by that research were not reproducible, then you at least have a basic foothold where you can say, hey, why are these results different? So where are the changes in my data compared to their data? On the right, you see here a screenshot of SciPy. SciPy is a tool that I use a lot in my work, and it has a lot of code embedded, a lot of code just pre-written that I can use. And what that allows me to do is it doesn't just mean, hey, it's transparent. If something doesn't work in when I'm using SciPy and I don't understand why, I can actually go into the very source of this, figure out where the problem is, and understand it or even fix it if there are any problems with it. But usually what I use it for most of the time is I can just install SciPy and use a lot of equations, a lot of functions just out of the box. So instead of having to write code from scratch, I can often save, well, not even just hours, but days or weeks of work by just reusing code that other people have written before. What it also allows you to do is it prevents you from repeating mistakes that were made in the past. And mistakes are not necessarily a bad thing. If I do some research, for example, the stuff that I did during my PhD, I found out that a lot of the things that I looked into, they just don't work. And often if you have an idea and it didn't work, that means you can't really make a nice publication out of it. And often, especially in a couple of years ago, because publishing is expensive and difficult to do, that information is often lost. Now, what you see here on the right is the so-called Dark Reactions project. What they've got here is they have a lot of experiments, and these experiments are shared on this website. And with this knowledge, so with this shared information, you know whether an experiment succeeded or not. And you can just search through this, and with that, figure out, hey, is this something that has been done in the past? And if you found that it has been done in the past and it didn't work, well, that's good to know. Then you know that perhaps it's better to look at a different solution. So I think you'll all agree with me when I say that the scientific advantages of open source are very clear. It's very straightforward why you would want open source in, well, basically any kind of research. It really follows the scientific method. However, one thing that's more difficult is applying open source in a commercial project. So it's good if you have a scientific driving force, if you have an idea of what you can do with this, and maybe the idea to really improve the world in some way. However, to really allow for large-scale adaptation of your idea, you'll often need to come up with a commercial application. Now, this is, of course, what companies are doing. And within companies, you rarely nowadays see that companies share their data and just do research, for example, and fully share their outcomes of that research. The reason this doesn't happen very often is that if a company knows something that the competition does not know, it gives them an advantage. It gives them added value. And another problem with open sourcing your data is if you've made a mistake, you're often being held responsible for this mistake. So in other words, it exposes your work to scrutiny. However, if you share your idea, it is possible to, because the price is free, because you're completely transparent about what you're doing, it is possible that your idea is much more widely adopted. And if it is indeed picked up, so if your technology, I don't like to use fancy words too often, but let's say if it goes viral, it will be adopted by many people, and with that can be improved by many people for free. So you don't need to spend your own workforce on that. People in the community are going to do it for free. And you as a company, if you've started this, you still know the product better than anyone. You've probably developed the very basics of it. So you have a very strong lead compared to other people that might be using this product. And with that, you can still often find commercial exploitations of what you want to do. And with that, as a company, it is definitely possible to come up with a product that's open source and still make money of it, which is something that many companies, well, need to do because of their stakeholders. Now, one of the companies that did an incredibly good job at this is the company Red Hat. Now, I asked before if anybody knows Linux. Red Hat is a specialized distribution of Linux that often runs on servers. What these guys are doing is they make changes to Linux, to that free and open source version of Linux, and just make that available to other people for free. What they then do is while they make a product that's free, they also are able to write trainings and give trainings and allow people to request support from their team. And that's how these guys are actually making their money. And they're doing a pretty good job at this. Red Hat is one of those companies that's been around for a very long time. What they do is they are developing a free product, but they make a guarantee, for example, for 10 years of security updates. So they make it much easier for you as a system administrator or someone running a server to not have to worry about things that are happening in the background as much. They take care of that for you, and they do that for a price. Now, that price is still low enough that many, many people are using this service. So moving on to the last part of my presentation, I want to talk about a few things that I've picked up while I've been doing the software engineering, the scientific software engineering work, and while I've been working at VS Particle. And hopefully with these things, you can benefit from that as well. So the first thing I wanted to talk about is how you can store data. For small amounts of data, it's something where the file size doesn't really matter. a very good solution that I would recommend you look into first, it's not always possible, but it's a good first thing to go to, is to use what's called Json Object. The syntax for a Json object is visible here in the bottom. And what you can see here is this is quite readable. You as a human can read this, and I think you'll directly understand what I'm doing here. I've done some experiments where the material I've worked on is gold, and the carrier gas that I've been using here, for example, for a G1 is argon. And my data is in the timestamps and the voltage, the things that I've measured at these timestamps are the voltages here. Now, while this is human readable, it's also computer readable. And that is something that's a big advantage of JSON. There are alternatives as well, but they're generally much less compact, much less easy to work with. JSON is furthermore well-defined. And while it's well-defined and while the syntax is compact, it's not nearly as compact as other data can be. So one thing to take into account is this JSON idea. It's great, but it will not always work if you're looking at more data. And an example of more data is, for example, large databases or images even that you're processing, 3D data, anything like that. For this, there is really no way around binary data. And my general advice here would be, there are so many formats available for the things that you're trying to do. And each of these has some advantages and disadvantages. What I would recommend is do a search on Google, figure out which of these formats are the standards, and try and use one of these standard formats. Especially in storing data and sharing data, many of these formats are open source already. A very nice one to look into first is if you're looking for something that is storing a lot of data, but can still just be sent by email quite easily, look into an email. Maybe WeTransfer is actually easy because emails attachments have their limitations. If you need something that is shareable, something that can be sent to other people and shared, look into HDF5 as a format. This is something that MATLAB, for example, has been using as well, but it's something that Python can work with. And it's something where you can store many types of data in, at least. If you're looking for something that's distributable, so if you're looking for something that different machines can talk to, look into databases. A very famous one that's getting a lot of traction nowadays is MongoDB. And if you're looking at images, there are many, many possibilities. But one particularly nice one that I'd like to give to you is the PNG file format. PNG compared to, for example, JPEG images has the big advantage that you're not going to lose the data that's in there. If you use JPEG, it's doing some kind of compression. If you very much zoom in on a photo that you've taken with your camera and it's in JPEG, you'll often see that these pixels are a little bit blurry if you zoom in further. PNG doesn't have this. Now, there are many, many, many more data formats that you can use, and there are many, many, many more options. By all means, if you want to spar about this some point, just drop me an email because I love talking about these things. Another tip that I'd like to give you is related to the publishing of your work. In my opinion, the peer review publication system that we have right now, it is a big mess. What we need to do is, if I publish an article, I need to pay a lot of money to publish that article. That producer, the publisher of that article, then goes to peer reviewers who do the work often, who review my article and often don't even get paid for that. And then if you as a third party want to see the work that I've done and published, you'll need to again pay the publisher to look at my work. Now, luckily, this is something that's losing a bit of traction nowadays. What you see more often is that open access journals are making at least that third step. So others pay to review your published work. They're at least getting rid of that step. So with open access journals, of course, you can open the journal and the data for free. However, if you want to do this, if you want to publish it as an open access journal, you often still need to pay a premium price. I've got a link here, and that link points towards a database of open access journals, and it gives you a bit of information if you need to pay premium, for example, as well. So if you want to take a look at that link later on, as I said before, I'll share the PDF with you. There might be some interesting ideas in there. They've got thousands of journals in there. Another thing that I would strongly recommend you do if you feel, if you see the use of open source, is that you add your data to your publication. And it doesn't need to be that clean. You don't need to spend weeks on trying to get the data in the best shape that you can. Just chug it in there. And nowadays, machine learning algorithms, for example, they're very often able to extract the data that they want from your publication. So throw it in there. You've got nothing to lose. If it's allowed, you've got nothing to lose. Another interesting thing, especially for you, is to try and publish your work in that Hde Jcap database that I talked about. What's really cool is that this is a database that's very easily accessible. So if you did an experiment, turns out it failed, consider adding it as well, because you'll still really help other people. Another thing that I would strongly recommend is there are some loopholes, I'll call them here, in the rules that these publication systems have. And it's very often, if you submit your manuscript, is very often to share the manuscript before it is published on, for example, ResearchGate. I think, let's figure out actually, how many people know ResearchGate? Click the raise your hand button again if you know it. Excellent. Excellent. 2/3 of people, at least 3/4 of the people. Great. I hope you're all using it already. And I hope that you'll also consider adding your work to that data, to ResearchGate. I'll be honest, I did it this morning. I looked into it this morning and I found out that some people requested some of my published work. In the end, I didn't add it because for one of the journals, I was not allowed to do so. But I found out that the papers that I published, most of these papers are nowadays available for free. So after an embargo for a couple of years, sometimes you can often still download the paper for free just through the DOI, and you can download it from the original publisher. What I've got here at the very end, under the if legal part, is a database that a lot of very clever people built. And what it does, it tells you what kind of work for a certain journal can you publish on ResearchGate. So by all means, take a look at that link if you want to. Sherpa Romeo. Also, if you have used code to come up with your results, consider sharing that code on GitHub. And again, it doesn't need to be that clean. It doesn't need to be perfect. Just making the code available is already so incredibly useful. I did this on my PhD as well. I will not tell you what my GitHub is, because I'll be honest, the code that I wrote in my PhD wasn't as nice as the code that I write nowadays. So it's a little bit embarrassing to look at my GitHub, but nonetheless, the code is there if anybody would want to continue my research. And for example, found out something that I had missed, they might be able to find a solution to say, hey, maybe this idea that you had and where you said this is not going to work for the next 30 years, maybe we can make some changes to it with this new knowledge and improve that. And that's one of the advantages that open source data really has. Now, with that, I have a couple of take-home messages just to summarize my presentation. I hope there's still time, Ale. Yeah? In my opinion, software engineering is a field where open source is very much mature and actually incredibly well done. And I would strongly recommend that we as a materials development community, we try and adopt some of these mechanisms that software engineering has taught us. Open source is especially great if you're in academia and if the work that you're doing is something that can really help other people. You don't necessarily have a commercial drive behind your product. If you're a company or if you have some sort of commercial motivation for the work that you're doing, it is something, open source is something that does carry a higher risk, but note as well that while the risk is higher, if it takes off, if the things that you're sharing really start to work, you have the chance to really have it adopted inside your community. So you've got a chance to, with your product, get a really high impact. And as a company, if you have a product with a high impact, you can always find a use for, getting money out of this. So even as a company, even as a commercial organization, open source is something to really look into. In this presentation, I've also mentioned a number of tools and a couple of formats for data that might be useful to you. So by all means, after the presentation, take a look at the PDF and see if some of these might be useful. And one thing that I didn't directly point out, but I found on the Material Pioneers website, we are working on a manifesto for the Material Pioneers. And in my opinion, open source can play an important role and can actually be a fundamental of this manifesto. I think there should really be something in this manifesto on open source. Now, as I mentioned before, I like talking about these things. If you have an idea or if you have a problem related to data and related to open source that you're not quite sure how to handle, how to tackle, contact me. You can find me on LinkedIn. I'm quite active on LinkedIn, but you can also send me an email at my VS Particle account. The links are in the bottom, and you'll see them in the PDF as well. So with that, thank you very much for your attention, and the floor is open for questions.
So thanks a lot, Thomas. I think you gave us a lot of things to think about, and yeah, could you share the PDF on the group chat?
Will do.
So everybody can access that. So if you have issues, just contact Thomas. In the meantime, do you have any questions for him, or about open source and data management, or anything he has been discussing about? You can just directly unmute yourself or raise your hand if you prefer.
If you have no questions for me, I do have some questions for you. But first, I have sent the PDF. It should be in the group chat now. Can you guys see it? That was the wrong button, but I'm back. Good, I can see it. Good, so let's share the screen again. Can you see it in full screen now?
Yeah.
Or do you still see a small screen? Good. Got a couple of questions for you, a couple of discussion items. First of all, I have advocated open source here. I'm curious if you are convinced that open source is actually always the best option, or if you think there are cases where you say, nah, I'm not going to use open source for this. Are there any opinions on this?
So
and we can also, oh, I see some comments, yes.
Yeah, they're having trouble downloading, so I created a document.
That probably has to do with this being a VS Particle setup thing. Ale, you'll find a way?
I'll do.
I should add you as the chief data scientist. Oh, thanks. I will also share it on LinkedIn. So I will, I've got the LinkedIn profile. I've shared the post there and I'll add it as well.
So Yasmin has a question. Yasmin, you can unmute yourself.
Yes, sure. Yeah, so just more of an answer to the question that was posed by Thomas. First of all, thank you very much for the nice presentation. And yes, whenever possible, I think open source is the best option, but of course there are cases when it is not possible because of having third company data or having personal data without consent of the participants. So these are also things that really needs to be taken into account. But apart from that, whenever possible, yeah, that is the best option, certainly.
Thank you. I think you make a very good point, actually. One of the things I did not mention is there are, of course, cases, there are fields where sharing data is not at all possible. When I was working at the previous company, I looked into a tool on LinkedIn that tries and collect data and gets an idea of, hey, this is a person that went to our website. This is a person that might be interested in the things that we're doing. This kind of data, this kind of personal data, even back then was something that was difficult and you needed to be very careful with. But now, especially with the, I think it's called GDPR in English, this new privacy law, this is something that you need to be extremely careful with and often just cannot share without doing a very good job at making your data anonymous. So very good point, very good contribution. Thanks.
I think also Pedro.
Yeah. Hey, Thomas, thanks for the presentation. It was really nice. Maybe can I ask you this question back? So I think, yeah, people working in academia, which should be most people attending, will find an easy solution for this, but I would guess in a company it's a bit more tricky. So how do you take this decision yourself or at VS Particles?
Yeah, that's a very good point. To be honest, I cannot fully answer your question. The reason being that I'm the chief data scientist, but I'm not in charge of any commercial things. So what we're going to do with the data that we obtain, I often pitch ideas, of course, and I've got some ideas and I've got a vision on how I think we should get there. But my vision is purely motivated from a scientific point of view. And what exactly we are going to do with the data, well, as I mentioned before, a company needs to find a way to make a profit. And VS Particle needs to keep this in mind as well. So I do know VS Particle, of course, started the whole initiative together with a lot of you people here on the Material Pioneers. So there is a drive to really make the data that we have open source. With that, hopefully make our technology get much more popular as well. But at the same time, we need to make sure that we can keep paying people's salaries in the short term and in the long term. So it's balancing out these things. And for me personally, what I try and do is I try and come up with a good idea. I do like thinking of, hey, this is a way we could commercialize this, but not just making the shareholders in VSP richer, for example, but also thinking about, hey, this is something that makes the world a better place. And I know that sounds a bit hippie-ish of me to say, but that is something that motivates me personally. And that is something that, that carries a role as well when I try and come up with ideas within VSP. Does that answer your question?
Yeah, I think it does answer. Yeah, I think it definitely gives a perspective onto it. I'll just try. I don't know if you can be a bit more, if you have more concrete ideas when balancing, for instance, innovation is like, as you said, higher risk but also higher impact. Would you find a balance between, very innovative stuff should be open source to get this high impact because it's also more difficult to get it across usually, and other technologies that would not be so innovative, then you would most likely not make it open source, like step improvements to previous software, for instance?
I think there's a good point in there. If you come up with something brilliant, then there is maybe a better chance that something brilliant might take off, might become really popular. So yes, I can definitely see that you say, hey, I got this amazing idea, and it is a high risk thing to make it open source, but it also would allow for much better adaptation. So definitely yes. For the parts where we make minor improvements, considering whether you're going to open source that or not, I think it's hard to generalize that particular one, because I can still imagine, for example, if I could make an improvement that makes the devices that VSP releases better and easier for everyone to use, I mean, that would still have an economic value if I would open source that. That would make it available to everybody. And if I, for example, would have sold you a G1 and my change will make that G1 better free of charge, and by giving away some of the knowledge that I have, there is still added value in it. So in that case, I would still say, yes, open sourcing. So hard to say. It depends on the exact situation, but I do strongly agree with, hey, if you have a really brilliant idea, consider making it open source, because you can make it really, really popular that way and reap the benefits from that as a company.
Okay, yeah, great. That's clear. Thanks, Tom.
I think we just have time for a last question. If there is someone that wants to share something or ask something to Thomas. In the meantime, I'm trying to still figure out how to share this presentation. Again, I'm not a scientist or whatever, but it looks like it doesn't work to share it this way on this chat. So we will drop you an email with our working link so you can download the presentation.
If not, can I use the last, I don't know, couple of minutes to ask one more question to you? And that's because we've got a lot of people together here right now. I'm very curious if there are any open source or well, probably open source tools where you think, hey, that's something that I found that's really useful. You guys should look into this as well. If you have any, because we are a little bit limited on time, can you just type them in the meeting chat as well? Because I'm curious to hear if there are any tools that I may have missed in my work and that you guys did find. So one of the things that I mentioned before is that database, that materials database. I never heard about it until I found through two of the people here that yeah, this exists and this is available free of charge and open source and everything. So any other things that I should look into, and other things that this community should look into, in your opinion? So while you guys are typing your answers, one of the things that I'll mention here as well is I'm a big fan of Markdown. Markdown is a way to make notes. So what I've done for this presentation as well, you can't see it because I'm not sharing the screen with you, but instead of using Microsoft Word, I've got this tool that I found, this language that I found, or this program that I found, where I can very easily make notes. And these notes, they look all right. I don't need to worry about formatting of my notes. And what's really cool is it in the end, it converts to a text file. So if I save that text file, for example, in my Dropbox or my OneDrive or my Nextcloud or any of my other file sharing services, I can just use text to search through this. So that's something that I'm a very big fan of. I see Yasmin shared Citable code. Never heard of it. I love that you're posting a link on GitHub, by the way, Yasmin.
You're very welcome. It is maybe possibly of interest. The idea is that it's actually quite nice that you mentioned it's possible to share repositories on GitHub. And if you do this, then it makes like a snapshot of your repository, and then you get a digital object identifier, and you also get a citation statement. So then people can directly cite you for the specific repository that you would want them to. And you get also a persistent identifier, so it never gets lost on internet, and you also get citations, so credits for your hard work.
Nice. Thank you for sharing. I'll look into it.
You're very welcome.
I see Anna posted Julia. I do know Julia. So Anna says, don't know if this will be useful for you, though. I know someone who uses it a lot, and from what I've seen, it is quite easy. Yes, I really like Julia. I've talked about Python before in my presentation, and Julia is in some ways an alternative to Python, but of course, like any programming language, it's got its advantages as well. One of the things where Python gets a lot of criticism is that if you write something in pure Python, so if the simplest version of Python without using the libraries, Python is notoriously slow. What Julia has done, Julia has a more modern language, if I'm not mistaken. It's a much more recently developed language. If you write something in pure Julia, it is still incredibly fast, without having to sacrifice how easy it is to write your code. So good point, Anna, thank you for sharing Julia. One of the things though, where I still feel that Python is, at least for me personally, a superior choice, all of the work that we at VSP are doing is generally in Python. Anything at least related to the data team is in Python. And one of the big advantages is then the adoption of Python, but also the libraries that are available in Python. So Python, it's got all kinds of tools that allow me, for example, to interface with high performance computers and all that and optimize it that way. Nonetheless, interesting one. I see we share. You can make all your papers openly available 6 months after their publication via university libraries. That's a nice one. I didn't know it exists. So that's sort of an alternative to ResearchGate in that way, and probably easier accessible. I should look into that. And I see that Pedro mentions overview of open science tools, rri-tools.eu. Looks good. Don't know that one. Oh, it's still loading for me. It seems to be stuck. I think everybody clicked the link. Hey, if more things come up, I would love to hear about them. I will write these things down and look into them. So thank you very much.
So again, thank you so much for joining. We share the presentation of Thomas with you, and we'll also include all these links because, yeah, it's definitely very interesting insight and very interesting content. So you will receive an email from us with all this content, and yeah, share it because it's open source, right? So thanks a lot, and you will receive an email for our coming webinar. It will be about AI and machine learning used for material science. This is going to be our last webinar regarding the topics of material pioneers and UCAT. We will have the actual last webinar, which will be the presentation of the manifesto, and it will happen later next month. And also for that one, you will be asked to collaborate with us because the manifesto needs to be shared and co-written and co-signed by all of us. At least that's our aim. Thanks, Thomas, and thanks to everybody that joined the webinar today. Thank you for the fruitful discussion. Everything we discussed today will end up in the manifesto of Materials Pioneers. This manifesto will be crucial for understanding how to speed up the process of materials development. If you're interested in knowing more and watching also other webinars about the other 5 topics in materials development, please register to our website, materialspioneer.com, where you can find all the other webinars and you can find registration for the coming one. The coming webinar will be about AI and machine learning for materials development. We will have a team of experts in the field that will guide us through this jungle, and we will better understand how to use our tools to enhance our research. Thank you so much, and see you next Tuesday.